I guess we should start with the history of Owl Mountain and where we got started. And I've been in model railroading for well over 30 years now, and got my degree in manufacturing technology in the mid-2000s in San Diego. I was a member of the club in La Mesa since 1996 or thereabouts. So I was there for about 10 years. I got my degree in manufacturing technology. Kind of always had this idea in the back of my mind that something like this would be what I'd really enjoy doing. And I worked for several other companies doing manufacturing stuff, machining, CNC jobs, things like that. But when I got my degree, I'd done a lot of work in the CAD/CAM side, and there wasn't really a niche for that specialty where you've gone in and done the computer-aided design, and then they kind of separate everything and expect you to either become a BS degree engineer or you're going to be a button pusher for the rest of your life working 8 hours a day on a CNC mill. And I had done better in school, and I wanted to do the higher level design stuff, but I didn't go for the engineering degree. So it turns out in the crash of 2008, that was a real problem. So then I turned back to my model railroading side and said, well, maybe I can do stuff, as some of you guys have done, you know, custom modeling, DCC installs, things like that. So I did that for a couple of years. So you see on my business card, it says, you know, custom modeling, actually. And I'm actually phasing that out because I don't have time for it anymore. And I've decided that the time it takes to put in one decoder, get one engine set up for a customer or whatever, you're going to be doing that. It's an 8-hour job, 8-hour-a-day job again, because you're just going to keep going over the same thing, just grinding out more models. And you know, you're never really going to be able to make a living on it. You're never going to be able to take a breather if you need one. And you know, most of us that have done DCC installs know that you can't do that 8 hours a day. I mean, you're going to get fried. So, and that's one of the things I learned in manufacturing is I don't do well with 8-hour-day button pushing jobs where it's the same thing. You know, eventually you're going to cut your hand on the machine or something, and you know, bad things happen. So, keeping something new going all the time was something that I kind of like to do. I mean, I have the interest to keep going and get the thing done, but I wanted something that would give back a little bit more net return interest type thing instead of just doing a one-off model repeatedly and then not even being able to enjoy it because you sell it to somebody else. So we did a couple of projects early in 2011, and I met some people. We were able to work together professionally, things like that. So I had some contacts that most people don't end up getting. 3D printing, even now, is not quite where it should be to be able to do full production. Some of you that have been following the company have seen that about 6 months ago, Shapeways that we were working with had some issues, and so we've withdrawn basically all of our 3D printed projects from the market currently. We are looking for another manufacturer to go with on that front. But again, the 3D printing, it's really expensive. You're only getting a couple models. So if it's one really cool, crazy thing, yeah, maybe you'll do 3D printing. Maybe somebody will be willing to pay a bunch of money, but it's not the same level as injection molding. It's not the same quality as cast brass or etched parts, things like that. And so I became a firm believer in about 2010 when I really started getting into doing Owl Mountain and came up with a company and started it with a family, with my family as partners. We'd noticed that people that do laser cut models, beautiful stuff. There's certain things that laser cut models do great. There's certain things that photo etch companies do great. You know, there's certain parts that's what you need to do. There's certain parts that are injection molded, but there's certain parts that shouldn't be injection molded because they're not going to be durable. They're going to break. Diesel handrails, for example, maybe. You know, I'm sure some of you know what I mean. So what we decided was that we were going to use the preferred material for whatever the application was. So, for example, one of our early projects was the passenger car tailgates. And I think I have some examples around here. I didn't get them out yet. Those were an interesting mix because on the market we had cast brass or cast metal tailgates for a passenger car that goes on the end of the car. We had the gyrolite casting for our diesels. You know, we can drill those out. We can put an LED in there. It's quite a bit of work. How are you going to deal with the LED not shorting out against the metal tailgate? That's kind of a problem. So that's one of the things that we addressed in our first injection molded project, actually, was the entire tailgate and a separate marker were going to be done in plastic. And it was going to have a cavity cast into the marker, into the gyrolite housing for an LED. And so once you assembled it, you could put it all together and easily get a tailgate for your passenger cars for the mid to late 50s up through the 70s. So again, with the club, I was looking over the passenger fleet and going, you know, it's really handy if we have markers. And I'd mocked a couple of these up before we went into production. And we decided, you know, this is actually going to work. We could actually need like, you know, 20 or 30 of these to get these on the rear of our trains and things like that. And when you couple it mid-train, the marker disappears. It's great. It's not like the corner markers where that car is always the rear car of the train. So we decided, okay, this will be our first project. We're going to sample the waters in injection molding, and we're going to do this because the club's going to need a couple hundred, you know, 100 maybe. We have a pretty good passenger car fleet. And so we did fairly well with that. And we also, by that point, had done some brass castings that were being done off of our pattern, so tank car safety vents, things like that, that were not available. And so we were kind of getting our feet wet in the brass casting market. Then in 2014, we came out with our first set of lumber load kits, and that was for these lumber loads that were wider for flat cars. They work on the Red Caboose SP models, F70 series flat car. They work on Proto 2000. Basically, all the big flat cars on the market right now, those loads work on. And those have met fairly good success. And then we were working on our first freight car kit, which is these here. And if you notice on these freight cars, we're using about 4 sprues of plastic parts, which are these. And we have weights included. And one of our concepts was, I don't want our customers to have to go back to the hobby shop to get prototype train. Good sound effects. I like that decoder. Excellent bass reflex speaker on that one. Yeah, there we go. So what we ended up doing was, we want you to be able to get a kit and not have to go back to the hobby store for anything other than your basic hand tools, your basic assembly tools, and your glue and your paint. We're still going to be a testers. We're going to be a Revell. You know, we want to be at that level of skill level for you guys to be able to build kits. But we want to be able to have the Academy Minicraft, you know, tangent model, et cetera. You know, we want a high-end product as a result. But it's going to take a little bit of skill, and hopefully people will be able to learn the skills either using our kits or using a competitor's kit, something like a Tichy kit, as a stepping stone. And maybe you build one Tichy kit, and then you jump up to doing something like this, and it shouldn't be that hard. One of the things TSG and I have been doing is we're starting to do a little video clinic on the lumber loads, so that I want to get some video footage of how to do these weathering effects so that you can turn a piece of plastic like this into a set of weathered wood like this. Yeah, you know, all of these lumber loads here are plastic. They're not wood. That's all painted on effects. And it's fast, and it doesn't take a lot of time, and the paint is cheap. You know, so it's one of these things. Learn the skills. It's not that hard, and you'll be able to do a lot with those skills. One of the things we learned at La Mesa was that car center of gravity was actually a major thing. If you have a car and it wants to stay upright, like this one, you know, you can incline it to actually a little past 90 degrees, and it will self-right. Okay, so if you can keep the weight as low as possible in the car body, the car will be not the first one to derail. And that's kind of the game. You know, it's like a game of musical chairs. The car that is first to fall over is going to be the one that's not sitting down at the end of the game, and it's going to be the one that comes out as being the problem, right? So we want the weight as low as possible in the car. Well, if you're going to put a full solid chunk of plastic or wood or anything really, if you're going to raise the center of gravity of the car to the point where it goes over 15 degrees and it wants to lay on its side or turn all the way over, like certain models are on the market, that's not a good thing. You don't want that in a car. And so our lumber loads were designed to minimize the amount of weight inside the load. So we wanted to make them as close to hollow as possible. And if you actually look at the difference between the 3001 series lumber load that's wider and the newer 3004 lumber load interior, we've thinned the edges of the load considerably. It's a lot thinner, and it's cutting down on the weight. We're also getting a little bit closer to the ends of the openings here, so that it's, again, pushing the limits of how little plastic can we actually use to get the effect. preferably I'd actually love to go to the point of, I think I did it on this one, I've marked where I might actually cut out the inside of this one. I'm not probably going to, but it was a concept. But maybe the most effective way would have been to reduce only half the thickness, but that reduces the ability of us to flip the load over the top panel and get a different whole effect of the wood. So that's one of the things about these pieces is they're modular. So like Design Preservation did with their buildings, you can shuffle these into any combination that you want. And I actually talked with a guy that's a very good with math, better than I am actually. And he said basically with the simple 3001 kit, which has 32 panels in it, there's something like 10 to the 7th power combinations that you could do in theory with all those pieces. So the real question then becomes, who's going to collect them all? You're going to have almost an infinite number of combinations. So you're not going to have duplicates. The human mind is really good at being able to detect patterns. And so when you see a train of cars going by and they have, say, some of the cast resin lumber loads, which are really cool. I mean, they're beautiful models. But if you have, say, 3 or 4 cars of them, your brain is going to figure out, hey, those are supposed to be random. Those are all identical. And it's going to have you're going to mentally, subconsciously, you're not going to appreciate it quite as much because it's not natural, because it's not random. And so one of our main reasons for doing this modular system like this is La Mesa needs like 100 to 150 carloads of lumber for both the Southern Pacific and the Santa Fe. So, I was like you guys, let's build some real wood lumber loads, that's great. And, the club has like 15 lumber loads, that's great. Well, they get damaged. I mean, these can get damaged too if you're really abusive to them. So, number one, they get damaged. Real thin pieces of wood are kind of fragile too for all the bracing. So that was always a problem. Cutting all the pieces of wood, I think each one of these pieces right here, that's 22 pieces of wood. Okay, and in one shot. And we can clean one of these up coming out of a mold in about 10 seconds. I mean, John saw me today, we were sitting there in a file and you're done. You're done. No big deal, and then you just move on to painting. And I remember spending hours playing with individual sticks of wood trying to build a couple lumber loads. And then you sit there and go, man, the club needs 100 more of these. I'm not going to be doing that. It's not going to happen. So that was one of the reasons that we started going into the lumber load market was because, again, the club needed like 100 of something, and I'm sitting there going, if the club needs 100 of something, that might commercially do okay. There's at least some kind of a market there. And the first load proved that we were pretty much right. There was a market, and again, now with our 2 new lumber load kits that we now released in the last couple of weeks, we're now getting into being able to do the lumber loads for our flat cars, which we weren't able to do with the previous load. The same kit works in gondolas, like this is a red caboose car from the club here. The 3005 kits are 3 stacks of lumber, so basically this is your kit for the 3005, and those are designed to fit in your 52-foot 6-inch gondolas from Tangent, Tichy, and Proto 2000. So again, it covers a large number of models that are on the market for the early 1950s, 1937 to 1970s. And of course, these lumber loads are random board end, and in the 60s basically is when they started going to the cut ends and using the steel banding to just cinch them down, and they were all cut very close to the same length. So that's basically the end era for these loads, is before they went to that clean cut look. And I have seen a few photos of this type of load even into the 70s, but it was definitely going to be a more rare load at that point. You're not going to see trains and trains of them. So, if you're modeling, say, before 1960, these are actually some good loads that would be very versatile if you wanted to model quite a few cars worth of lumber. Some customers don't put a base coat on them. I don't think that's quite as good because I like having a base coat, and it doesn't even have to be a primer. The gentleman that did a MR article this last month featured our lumber loads in it, and he was using, I think, some kind of a gray primer first, and then he was going into another color. I found that I don't really need to do a gray primer. We are molding the load in color, so it's roughly the right color. What you really want to do is mist a layer of color over it, which is roughly the same, maybe a slightly different shade, doesn't really matter. But you want to give it a little bit of tooth so that your later weathering effects will have something to stick to. The colors I'm basically using is, to me, a wooden deck tan, which is almost a direct match for this particular color that we chose. And then it turns out for the weathering effects, I'm using apple barrel from Walmart. And that stuff, you get a bottle this big for 50 cents, maybe 87 cents, something like that, depending on the color. And so for like $10, you can have like a full selection of earth tones and blacks and blacks to whites, weathering tones, all that kind of stuff. You can basically have all of that. Get some cheap $3 brushes where you get like 5 brushes for $3. The ones that have glitter in the handles, those are great. Because some of the techniques that you do to do this style of lumber does become abusive and destructive to the brushes. So you don't want to be using your red sables, you don't want to be using your horsehair brushes, you don't want to be using your $10 brushes for doing this stuff, because you are going to be doing a little bit of scrubbing, you're going to be doing some techniques where trying to get down into certain areas, the brushes start pluming out and looking like an afro or something like that after a little while. So the problem is, again, you're trying to keep your material costs down. I mean, that's one of the things. I don't want to say, oh, you have to do this really elite thing. You have to know how to use a double action airbrush like this and this and this. When something simple like this is the way to go, and you can do a lot with very little. One of these pieces can probably be done in about maybe as much as 5 minutes for one panel, but it depends how much you want to do and depends how the color's coming out, depends what you think is what looks like wood. And that's one of the things that I always found when I was doing this. People come up and ask me, well, what color did you use? And it's like, something that looks to me like wood. That's kind of the most honest answer that you can come back with is, I choose maybe from like 5 or 6 basic colors, maybe even only 3. And then from those 3, you're mixing, and sometimes you're even mixing on the palette, the panel of wood to blend and get your streaks and stuff for the wood effects. That's all coming out of just the interaction of the various colors of paint. In about, I think it was around 2012, we paid to have this poor, sad hulk of a car made on a 3D printer. Cost about $120, kind of. You sit there and go, man, that's expensive. And you sit there and go, well, yeah, this is why we don't do 3D printed freight cars to run on a club layout. This is why we don't print 3D printed models to become high production freight car models or something. They are just too expensive. And this was a beautiful sample that was made, but this was actually done in a material that was rather brittle, so it broke a section of the deck off. You'll notice that it's kind of silvering. That's from being in a hot car for a while when I was taking this to shows for about a year as a concept development model. So this is weeping material back out of its 3D. The 3D print is basically dissolving in the heat. And so something like this is not suitable. And you can imagine what that would do to a decal if you had a decal over the material and then having it do that silvering effect underneath the decal. You think doing a decal and having a gloss coat and then not having the gloss coat perfect and stuff. I mean, can you imagine getting it perfect and everything's fine, 6 months later it starts coming through underneath the decal? I want models that are going to last 40 years. These injection molded models here, we know the properties of ABS plastic. We know the properties of styrene. We know the properties of our paint that we're going to be using on it. We know the properties of the glue that we're using on it. We've been playing with these parts, these basic chemistry experiments for 60 years. So we're pretty confident that something like that. I mean, you look at an Athearn model from the 1950s or 60s, 70s, and you sit there and go, okay, this car's almost 50 years old. It's maybe getting a little brittle because the plastic's gassing off a little bit, okay? But the thing still runs on the layout. It's still fine. You might put new trucks under it, but the model will work. Something like that, I have no confidence that that model is going to last 10 years, especially in service. I mean, it's only like 6, 7 years old right now, not even that, and it's starting to fail. So basically, the 3D models are a testing ground for our 3D models in the computer. So we design something in the computer. We decide to split it up, make a model, decide how we're going to break the parts off, and basically make all of these parts. And I can hand out some of these and pass these around. I know I was going to save these for the next time a train came by, but you guys can look those over. This is one of the brake shots. That's a very fine detail part. We actually didn't bother 3D printing the brake shot ahead of time because we decided that was too fragile, and those detail parts are best just done straight into plastic. We weren't going to worry about the fine details of that. So that first model that I passed around there, the early development model, was the design concept proof to make sure that all of those parts that you're holding now were actually going to be able to be made, that they were all fit together. As a final proof, before we actually went to tooling, I tried to have this one done, which was, we'd made changes. You know, it's one of these things, let's just double check that we actually have a good print. Well, that one didn't work. As you can see, we tried print, we got greedy, we decided to try it as one shot, and the printer wasn't happy, and the print failed, and then some of the post-curing didn't exactly go over very well either. So, but it was, again, it was a good enough print that I knew that most of the details that I was really worried about were going to work. I got to the point of not worrying about it. The guy that did the 3D printing for me said, well, we're going to have to make changes to your model to be able to 3D print this. And I said, that's not going to be a good thing. You know, I don't want to make the changes to make it 3D printable when we're going to be doing injection molding. So we went for the injection molding. But it's a good idea that I believe to spend a couple $100 and make sure with a 3D print that you're going to get what you want when you actually pay, you know, 4 or 5 figures for getting the actual tooling done. And then, you know, it'd be it could be, you know, easily $5,000, $10,000 if you make a mistake and have to have the tooling changed. So, and being a machinist, I know what's involved when that kind of a mistake happens. So when you sit there and you go, well, why isn't Athearn or somebody fixing this thing in their mold? You know, they're going, it's not worth it. You know, they might have to start over again. And that's happened a couple times. We've had to do molds over again. And that's really painful because now you're back to square one. You have to go get another piece of material. You got to start all over and do it all over from scratch. You'll notice on those 3D prints and stuff that I've handed out, there's a big opening in the center sill between the trucks. And it turns out we designed, and on the early 3D printed one, there's still a weight in the middle of that one. We designed a weight that would go from the inside axles, the full length, down to the bottom of the side sills. So basically, if you're looking at it dead on from the side, you won't see any weight. But the car is actually going to weigh about 3 1/4 ounces. So if I grab one of these cars, like this one, this is a Texas New Orleans car, hand that to you. First thing he does is he shakes it up and down. But what the first reaction is usually, wait a minute, that's not plastic. And you're right, there's quite a bit of lead in there. And we're actually using a lead alloy from Iowa. It's Adair Shops, and they do custom metal weights. Again, you wonder why about the price. We're having custom machined metal weights made for these kits. So, these metal weights, actually, I could have gone even closer on the tolerances. That guy is really precise when he makes the weights for you. And so that weight basically brings these cars up close to the NMRA. They're at 3 1/4 ounces with metal wheel sets in them. And yeah, okay, so NMRA wants, 375 or 3 3/4, somewhere in there. But a flat car, there's no upper body structure that's going to raise your center of gravity. So again, keeping the weight low in the car, that car is not going to be the first car to derail. And if you've noticed on the 3D prints that I passed around and on the model there, you'll notice the very restricted draft gear motion of the car. There's a very small amount of movement of the coupler side to side compared to like a KD5 box. We went with a very, it's as close to scale as we can get and still get enough side movement in the coupler. We found that in train, when the cars are being pushed on by a helper, for example, or you're switching a heavy cut or something like that, having the coupler being able to move sideways up to 1/8 of an inch off center, which is what KD5 boxes do, introduces the whole problem of being able to buckle the cars, and then the lateral force pushes the car and derail, right? So that's what causes your cars to go clunk like that and jackknife, is the couplers are actually helping throw the cars off the track. It gives them a lever angle to be able to push the car sideways. So what we did is reduce that, and it turns out that what ends up happening is the force goes straight through the car. And so when I tested it, and I tested it at La Mesa with some very bad train handling, which I'm ashamed to, I'm not supposed to say that because we're supposed to do better down there. But I tested the cars, and we were able to push about 40 cars getting back into a 2% grade, and the engine was right against this, was an Intermountain cab Ford with one of those really long couplers. And so that long coupler was really wanting to go off to the side and pull this car off the track. It didn't derail. It wasn't the first car in the train that derailed. It turns out another lightweight flat car was the first car to derail. And so I pulled that car out and kept going with the experiment to see when this car would derail. And when it finally derailed, it was because the Intermountain cab Ford had so much lateral on a long shank drawbar. It was probably coming close to 1/4 of an inch of offset from center line. And this draft gear is not designed to go that far off center, and so literally it finally pulled this car completely off. But it's one of these things where if it was not right ahead of the helper, and the helper didn't have that long of a draft gear, it wouldn't have been the first car to derail. And again, I was doing something really, really stupid. In normal operation, you should never get to the point of having that car have that kind of situation. We found that these restrictor draft gears can go down to like 15-inch radius. I mean, you can go down to the point where the corners of the car body actually hit each other. The KD couplers have enough slop in them to allow that extra radius operation. The only thing this really won't do is delayed uncouplings on an 18-inch radius curve. So at a certain point, you just can't get the couplers to go like this and then go into a curve. So, okay, fair point. If anybody does need to go into those situations, there's nothing stopping you from filing the coupler box opening a little wider so that you get that extra lateral play. So anyway, there we go. We go into production. The cars turned out pretty well. Our next projects, again, going back to 3D printing, here's a car with sideboards. We 3D printed the sideboards. So again, a test for our next project. And then this is an early concept model for one of the Blackburn sugar beet racks that we're going to be doing. Sugar beet racks that we are going to do. Can't say that 3 times fast.
The car with the 3D printed sidewalls, is that going to be an add-on to a black car kit?
Yeah, it'll basically be equivalent to one of these load kits. It'll be in the 3000 series as an add-on kit. And these were used, some of our research, a gentleman in Texas, I believe it was, Galveston seawall, and there's pink granite down there in Texas. And they use it on a lot of their government buildings, things like that. They actually shipped it around the country. And they were shipping a lot of that kind of stuff. The smaller pieces were being shipped with cars that had high side gons. And there was a gentleman down there that turned me on to that information and said, oh, I need like a dozen of them, and I need them for pink granite service. And I'm going, pink granite? What's this? If it's enough that you're modeling the layout and you need 12 of them, I maybe should learn about this. So I did a little bit of investigating, and so we'll be coming out with some sideboards. The other thing with the sideboards that's kind of cool is they were used on maintenance away cars in supply train service. And there's a great clip this is my railroad steam version. I think the 1954 one might have the same cut in it, but the earlier one certainly does have the cut. And you see an overhead shot of a train going by with about 3 of these sideboard flat cars, 40-foot flat cars. And in that era, these are the only cars that could have been. And a lot of these cars were going into maintenance away service, some in the 30s, and then a lot more in World War II, and then quite a bit in the late 40s, into the 54, 55 era. There were quite a few being retired. So that'll be a fun thing for people to have on their layout. I think maintenance away cars are a little underrepresented in a lot of modeling because there actually are a lot of operational options for, well, what are you going to do? The car could be in track and maintenance service. It could be in supply service. There's just all kinds of fun things for those to do. And our new Blackburn beet racks, we're going to be designing 2 different styles of the rack, which was common in the late 40s. From our research, it looks like that design was mid-20s was when they went to that particular flavor, and they stayed around until about 1949, 1950, when the composite GS gons like these were being built by the SP, or for the SP. And that's when the beet traffic shifted over to being hauled in gondolas instead of these rather rickety beet racks, because these were all wood. I mean, that's the amazing thing when you think about it. This was all wood. There's a few pieces of steel in there, and then there were tie rods holding the whole thing together. This 3D print, of course, the tie rods are way too fine to be 3D printed, so we left those off of this sample. And the sample, we're planning to have these little indexing keys on the bottom, so it will actually kind of click into the top of the car. So again, in most operating situations, you won't have any problem with the load falling off. I mean, unless the car fell literally over on its side. Yeah, and we're going to do a beat load to go inside it. We probably are going to end up doing a load and an unloaded version. So it'll probably be something like, well, this is a 5-board extension, so or 5-board rack. So we'll be doing like a 5-board rack empty, and then a 5-board rack loaded, and then you can buy the load piece separately if you bought the wrong one and you want to shuffle up what you've done. That's fine. But I was hoping originally to make the load actually removable out of the beat rack, but I'm not sure that that's going to fly. So right now the safe course is to say you will buy one rack to make it loaded and another rack to make it empty. And then the whole thing would basically be swappable on the flat car. Okay. And one of the cool things about these beat racks, and I don't think you've seen it from that far away, but there's actually a B number on the beat rack. So the SP was actually keeping track of every rack. And they seasonally were put onto the flat cars and taken off. And there's photos of them in Roseville with stacks 3 high. They look like intermodal containers, stacked up in Roseville, like 50 racks long and 3 high. And so they'd come by with a crane and pick them up and put them on the flat car for the season. And then when they didn't need them, they'd come by and take them off and put them back out as flat cars. Not to say that a rack couldn't stay on a car constantly for 5 or 10, however many years. But as they seasonally fluctuated, it seems like they were pulling them on and off. And so you could either do the same beat rack number and have a load in an empty flavor, or maybe you just do more numbers and swap the racks around just like you would be able to swap these lumber loads. You look at these lumber loads and you'd think, well, yeah, he's gluing them to the car. I'm not. These are completely removable. And so you can remove these and shuffle it up and change the look of this particular car. It'll take me a minute to nestle that all back down in there. But, there you go. How long did that take? Yeah, a couple seconds. Pull those back out, drop that one back in. So the idea that your fleet becomes committed to certain loads, because I come from a layout where we do operation, we're going to have a fleet of, say, well over 1,000 cars. We're going to have lumber trains of maybe 80 to 100 cars in some cases. Having the ability to have the loads shuffle, even if the cars aren't changing constantly, changing the loads around, you're not going to get tired of seeing that train, because every time you see it, when it gets loaded in a slightly different configuration, the loads are in a different place, the train looks like a different train. And so that's why all of these loads are basically removable. And you can see these actually are wanting to stick well enough that I'd almost pick the car up if I wasn't careful. But anyway, so all of these loads are basically removable. And when it turns out these flat cars, and the deck's wandering around out there somewhere, the stake pockets are contained. It's basically like a C shape with the deck overhanging. And many HO scale models have that configuration. So we decided on these flat cars to save on tooling costs and on modelers' time. Because, for example, the Red Caboose 70-ton flat cars that they did for the F-70s, they had separate stake pockets. And I believe those cars had 32 separate stake pockets that you had to glue on. And I did that for a while, and I eventually had an eye issue. And I don't think the eye issue is related to the building of these kits, but I don't know. Anyway, so for about 2 years, I couldn't physically see to do that kind of work. Even though my muscles could still do it, my dexterity was still there, it hurt my eyes to try to deal with that. And so one of the considerations we made was it's going to cost us a lot more on tooling costs to be able to actually make the die so that it could pull and make the pockets open. It's going to push the thickness of the plastic down to the bare minimums of being able to even inject and mold it. And they're going to be really fragile. And the real stake pockets are only 3.5 by 5 inches, I think it is, if I remember right. So they're really small. So in HO, you're talking about, okay, let's give, say, 5 thousandths clearance around that. Okay, we're talking less than 20 thousandths by less than 35 thousandths, okay, to get a scale stake pocket to work. And that's why when I started doing these lumber loads, we said, we're not going to be putting the stakes into the stake pockets. They're going to sit on top of the stake pockets. They're going to look like they're going in. And there's nothing stopping you if you are really so committed to having a scale-looking car. You can put the stake stubs going down below the stake pockets if you want. You can glue them on there. That's not a problem. You know, if you want to do that, that's fine. But the idea of actually having them, and this is again the experience at a big club where we were using live wood loads, real wood loads, with actual stakes that were going through Athearn stake pockets, and then you take them off and set them in a tray. They're now sticking this far up, and the entire load is standing on its stakes. How long is that going to last? Not very long. I think you guys hit the nail on the head on that. So I think with these, it's still smart to put a little bit of foam or something on the surface, because the stakes will stick down below the deck level to key into those notches in the deck. But you'll basically be locking these loads onto the car. And certain cars, say the Bowser F30A flat car, for example, beautiful car. Its deck is flush and it doesn't overhang. And the stake pockets are even with the top of the deck. So there's no way to key into those. So my recommendation on those is you drill a small hole, for example, of one set of stakes. You drill a small hole and put, say, a 20 thousandths piece of wire up the bottom of the stake, and then put that on there. And that will be small enough to go down inside the stakes and give it something to locate so it won't migrate off the car and derail. The flat cars, we are going to be doing eventually the single center beam version, which you saw that other print wandering around here, which is the F50-4. That will probably be the next stepping stone because it only requires changing 2 molds. And when we do that, that will open up being able to do Union Pacific flavor cars. And I believe the UP cars also had sideboards, so it'll give another outlet for the sideboards. After that, we're contemplating a UP Pacific flavor of the flat cars, but that will require new sides and new deck. So if we were contemplating the UP car right today, it would be a completely new car. So we're not going to do that immediately. It will have to be a stepping stone process via the Dash 4 car. Currently, we're not planning on doing the Dash 4 immediately. We're going to do probably these projects first, the sideboards and the beat racks. And then we're going to do a different freight car, completely different freight car. We don't want to burn out the market on this particular length and flavor and everything of these cars. We want to keep these in stock. We'd like to keep them as a stock. All these would be preferably kept as stock items, so anybody can get them at any time. Basically, you can order them from us today. You could order it from us a month from now. Hopefully, we'll not run out. If we do run out, it would be temporary until we could rerun the molds. The new freight car ideally will be one that's completely different, and then we can work our way back through these the 40-foot flat car flavor, or the SP cars and the UP, and then go back through those. But we're going to try to branch out into a couple of other freight car types. Again, prototypes that have not been done. That's one of the reasons that we chose these cars, is in photographs, these cars have these sub-deck blocks running along the side there. It creates a unique step side sill profile. And in a photo, even one like this, say from your perspective at like 7/8 angle, you can see the shadows cast from that profile in photographs way back in a train. And you can see those and say, well, I'm not quite sure which railroad's car that is, because I know that that kind of car was used by, say, 5 or 6 different railroads, but it's one of them. That's all I need to know. And so from that, you can say, well, is that an SP car? Is that a UP car? Is it an SP subsidiary car? At a certain point, you just have to say, well, we don't know, I don't care, but I know it's one of them. So you can get an idea how many of these things were in various photographs in various areas and just showing up. At a comfortable speed, not like feeling like I'm rushing and doing anything super crazy, I would probably say 2 evenings, because you're going to be doing paint drying time in between. So maybe I'd say 1 evening, 3-4 hours to build the car, and then probably 2 or 3 hours to paint and weather it on a day. Build it to the point where you can paint it. So comfortably, I mean, if you started like Saturday morning, by Sunday evening, I'd say you'd have a car. It's pretty reasonable. The lumber load kits, I have a funny story with that. In the early times when I started building these things, and for example, when I had only a couple of test shots. So it's kind of like you if you go to the store and get 1 or 2 and you go, I only have 2, I can't mess this up, you know. And so, and it's something new and exciting. And after the 10th one, you don't care. I'll tell you that. But what was really interesting was watching as everybody would get the lumber loads and they'd be sitting there and then, no, wait, I kind of like that. And then, no, I'm going to, you know, they'd sit there and fiddle with it. And I watched one guy fiddle with one for about 2.5 hours. And I mean, he had the glue bottle right there, and he fiddles with it, and then, you know, he gets to the point, and yeah, I like that. That looks really, no, I'm going to do this. Wait. it was hilarious. I don't, but what's funny is I did that also in the early days when I was tinkering with it. It took me like 6 hours to build the first one. And so when somebody asks me, it's like, how long is it going to take to build a lumber load? And I'm going to tell them about 6 or 7 hours. For the first one, maybe the second one too. But it's not because it's hard. It's because there's so many options with building it and getting it to where your artistic eye likes it or you feel happy with it or whatever, you know, whatever you want to call it. It's usually the builder that decides not to hit it with the glue for some reason that's internal to their own head. It's not because there's something hard with the kit or funky or anything weird. To give you an example, this load right here, I built that in about 3 hours flat. That was, again, to get stuff done, to get the kits into production, and I was on a deadline, and I had to get the load done. And I'd built the other one, and I said, I want the other flavor of it. I want one of the ones that's centered up, and I wanted a different flavor. So I said, I have to build one this afternoon. And it took about 3 hours. And I mean, that was literally cut it, sand it, glue it, paint it, weather it, put the stakes on it, take photographs. And it was about 3.5 hours. So if you're hard pressed to know exactly how long it takes, about 3 hours. It needs to be hard to do any other way, and it needs to be something that nobody else has done. Because I don't want to have another F unit on the market. That's crazy. It's not going to fly. And I don't, you know, on each project, you know, in a way, we're still a small business, and so each time we come out with a new product, we really appreciate the support of the community in terms of buying our products because we're leveraging each time. So if we did, say, the new lumber load kits and it absolutely flopped, you know, and we have a lot of our capital in this one project, you know, are we going to be able to do another freight car? No. When you look at something like this and you say, let's say that has 4,000 dimensions, okay? For, you know, how thick is every little bit, how tall is it, how, you know, all of the three-dimensional bits, all the features. Let's call it 4,000 items. If you have to go in and change 2,200 of them or more, and some of them are replicated, some of them are cloned, you know, fine, whatever, but let's just say 3/4 of them have to be redone. Which ones have we done? I haven't been able to keep track of which ones I've done and which ones I've not done. Therefore, because the time that it would take to go through and crunch, doing all of the little changes, and I've done a couple projects where I've gone through and done like an 80% rebuild. It's not fun. And I've decided that if I'm faced with another 80% rebuild, where 80% of the dimensions on the car are going to have to, or project are going to have to be changed, it's time advantage to scrap that project, start with a blank computer file, and just re-enter all the data. It's faster. You know, there's very few beat rack articles in the modeling community. There's very few beat rack articles in the prototype community. SP Trainline has done an article on it. A few people have done random photographs of something they scratch built and did off of photos. I'm not going to knock any of the things that they've done. They're beautiful models. It's great research that people like John Signer have done on the beat racks. Great stuff. But nobody has actually sat down in terms of, you know, Signer's article was a general article on the beats from the beginnings in the 1800s all the way up to the sugar beet racks at the end of the Southern Pacific era when they sold them to the sugar beet companies. You know, he was hitting the entire thing for all of California in one article. Great article. But he barely touched on the Blackburn racks. I mean, there's a few photos, there's a little bit of information, not a lot to go on. So I think given the information that I've spent some time seriously digging and scrounging and acquiring, I'm hoping to do a complimentary article in some kind of publication. I'm not sure what, I haven't even discussed it with anybody yet. But I think by the time I'm done building these kits, I will also be able to do an article on the beat racks that has more definitive dates of when certain things happened. From the information I've got, I think I'll be able to sit down and do some forensic analysis of dates and information on when changes happened and be able to say, okay, this date, this change happened, that date, that change happened, that date, that change happened, then it looked like this, then it looked like that, then it did this. So I think we can do that, but I haven't sat down to actually nail all that stuff down. But that's the level of, and we did that kind of research with the flat cars too. I mean, you sit there and go, well, why is it taking you 6 years to go from one of those early printed prototypes to having these? I think it was a design time of like 5 years. Well, because I was taking the time to go and do all this research and stuff like that, and research takes time and money. So, but the thing I didn't want to do was get a product to market and then have somebody go, oh, by the way, here's all the information that you got wrong. That would, we're not going to change it. It's kind of one of these things where once you get the model done, once you pay for the tooling to be done, the last thing we want to do is go back and have to change it. So I think that's something to really strive for. And I want to say, I think there's a lot of other companies that are trying to do well, and they constantly keep raising the bar in terms of how good their models are, how much detail they have, how how carefully they're following their prototype, even to the differences of having a nose on this and a radiator fan on that, and all this kind of stuff. And so, like our products, we don't want to be releasing kits that are faux pas, that are fictitious railroad names, that are incorrect railroad names. Well, but you'll sell more if you put BNSF on something. Well, they never had any of these. And I really don't want to take Owl Mountain into that realm of fictitious or false. I'm not going to say even fictitious, because fictitious roads are pretty cool, but I'm going to say a false history of a car that they never had. And in some cases, they never even had anything close. I don't want to even go there. I'm going to sell this car as an SP car. If you're modeling the New Haven and you want one of these, come up with a story of why one got back there. They were free interchange cars. They could have had one go back there. There's nothing stopping one from going back there. And that's what I've told a couple of customers. They're going, I modeled the New Haven in 1954. Could I have seen one of these? Yeah. Not maybe super likely, but there's nothing saying that the car couldn't have shown up there. So that's, again, one of the things that we're trying to do with the models is honor the history of where these cars came from over 100 years ago and be able to replicate that in scale. So I thank you for your time. If anybody would like to stay, we could do a brief thing on the weathering techniques. I could break out some of the paint and stuff like that, and we can do a little finger painting here if anybody interested. But otherwise, thank you, John.